tetrahedron. Kepler realized that if he took a sphere, put inside of that a cube, a sphere inside of that, a tetrahedron inside of that, and so on, that the 6 spheres that he got in that way had the same ratio of radii as the ratios of the orbits of the 6 planets. Kepler was absolutely convinced that he had discovered the secret of the structure of the universe. I have here the book in which he published that great discovery. This book was published in Tübingen in 1596. It's called On the Admirable Proportions of the Heavenly Orbs and so on. And in this book, there is a diagram showing his geometrical model. And here it is. Incidentally, there's something interesting about this diagram itself. This diagram has a date on it down here, which is 1597, a year later than the publication of the book. What must have happened is that the diagram, the plate, was not ready when the book was published, and so it had to be sent out a year later to be glued into copies of the book. Looking back on that incident, we tend to think that Kepler's picture of a sky full of cubes and tetrahedrons and so on is quaint and rather foolish. But I would like just for a moment to take it absolutely seriously and see what it was really about. First of all, in a period when almost no one else believed in Copernicus, this model is solidly Copernican. It makes no sense whatsoever without the sun at the center. The second thing you have to remember is that it's only much later, in the time of Newton, that we start to imagine a universe held together by invisible forces. Before Kepler, the universe was a planum. That means it was full, filled with crystal spheres. What Kepler was doing was replacing the crystal spheres with these perfect geometric solids. And so you see, Kepler's idea was both daring and yet solidly in the scientific tradition of his time.